Hey everybody, this is Larry. This is day 12 of the November Leetcode Daily Challenge. Forgot what month it was. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem. Seems like it's easy, only because they tell me. I don't really like classifying them, but alright, let's give it a hit. We're linked list, we wrote node that has returned a new head. Okay. Just removing nodes. Okay, they already did the one, but the one thing that I was going to say is be careful about an empty linked list. But that is one of the test cases, so unless you forgot about the test cases, should be okay. The way that I always think about it, or at least maybe more recently, I don't know about always, but is to have a sentinel, right, of a something that begins like before the head, so that so yeah. Oh, I guess -1 and then x or something like that, right? So then now you can kind of, and the way that I always talk about linked lists and even trees, depending on the problem, is draw it out. Anytime you have pointers, and when I say pointers, every, I mean, I know I'm hand wavy a little bit for people who actually know the semantics to be direct. I'm only using it a little bit on a more English term, so please forgive me if I'm, it's me trying to be explain it in a way that is more understandable. But I know how these things work per se. But anyway, but try drawing. Roughly speaking, every variable is points to something. It points to a reference in data. So every time you move something or set something to something else, you should just draw it out on a piece of paper or something like that, so that you can kind of see how it moves and make sure that every step of the way it is what you think it is, right? Of course, you don't need to do this on paper. You can do this, programming it or whatever. But these are the things that I would say to get started. But this is an easy one though, so we should be able to go okay. So we just start with current is equal to sentinel, even though maybe it's like a sentinel head, and then while current is not none, current is equal to current.next. Of course, this is just essentially like a for loop of just moving. I always write them together because otherwise I don't always, because I still forget it from time to time, but I try to write it together so that it saves me an infinite loop because I'll forget it later. So then now, okay, so if current.row so this is something that we have to think about, right? So there are two things you can do. One is either you remove current if current.row is equal to row, or and keep track of the previous link, or you could look at the next, and if the next is equal to row, then you get next equal to next or something like that, right? How do I want to think about it? So the case stat is a little bit tricky, or just to make sure you think about, though it is also in example 3, is that you might repeat removing something. So I'm going to do this with respect to keep track of, I should say previous is equal to sentinel, and then current is equal to previous.next, and then we do this loop. If this is the case, then previous.next is equal to current.next, because now we get rid of the current.next, and then current, and then I think that's all we have to do, maybe. And then we just have to return the sentinel, which is the fake thing that points to before the head, and then the next of that. Maybe this should be okay. Let's see. Not that I'm missing like off by 1 or something. Okay, so I removed everything, which is a little bit sad, but why do I remove everything? Is this set up correctly? I never know. I think this is right though, but okay. Well, this part is right. Well, maybe I have some weird typo, but okay. Let's say I remove this for debugging, and then see if that should just return the initial. So, yeah. Okay. Okay, so this is what we expect. Sometimes you want things to kind of make sure that it is what you expect and not necessarily, you know. Okay, so while current is not none, huh, why is this wrong? Basically, the previous is next is equal to the next one. So you skip this current node, and then we go to the next one, right? Did I mess something up? But why does this true? Oh, I don't update previous.next. Whoops. So okay, so in this case, I forgot to update it. Man, I'm really sloppy today. But yeah. So now we think about it. The previous.next, we skip this one, and that's okay. But in that case, we do not move previous, right? So we only move previous if I think we don't even move the current, do we? Well, I guess we move the current. I guess we always move the current, and then else is previous.next is equal to previous is equal to previous.next to move this forward. Yeah, maybe. I think this is where I need to take my own advice and maybe draw it out, but it seems okay. Let's actually run a few more test cases. Yeah, a little bit sloppy, so I don't know. I guess they're really, so get rid of the first element, get rid of the last element, and I think that's probably it, because the other test cases seems pretty representative of the edge cases that I would come up with. So if this is good, I'm happy about this. Yeah, let's give it a spin. Hopefully I don't get a wrong answer like last time. Cool. Yeah, I mean, I don't know what else to say. This is, so yeah, so just be careful apparently, but also just make sure you know, because right here, for example, what I said, there are 3 pointers kind of. One is a pointer to a node, the other one is the previous pointer and the current pointer, and make sure that they move one at a time for both cases, which is this one. If they're equal to value, oh, what the hell did that happen? If they're equal to value, the previous next, you skip the current one and then you move forward. Otherwise, the previous goes to the next one, which is the current node, and then you move the current. So yeah, so make sure you work for the cases and just think about it through. Of course, this is going to be linear time and constant space. We only allocate memory for this node and a couple of pointers. And of course, this is linear time because we just go through the loop, right? Cool. That's all I have for today. Let me know what you think. Yeah, these kind of problems, I would say, comes up maybe not as much anymore. Maybe it's just not the meta or in vogue. It used to come up in a lot of programming interviews, but these days I think people just go for something a little bit different. I could be wrong though. I just haven't seen it, or my peers haven't asked it as much, but at least that's just recently. Yeah, I don't know. Anyway, that's all I have though. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.